Okay, in this video we're going to take a look at the distance condition because the distance condition does some pretty special things for us. We're going to use our TP tools icon, which is just kind of a custom rollout with some common functions. This is going to be updated and included on the DVD so you can use it. Basically, it just creates a TP for us and does some other utilitarian things. But we want to take a look at the distance condition. So we're going to actually create two dynamic sets. One of them will be birth and another one will be distance. And we actually want to structure our rules, our dynamic sets in a way that we could save them out as a black box later if we wanted to. So we're going to go ahead and create this first level dynamic set, and we'll call it distance condition. Okay, so here in birth, pretty simply, and we're going to need some particle groups. Let's call on a black box that we had created called colors. And we don't need all these colors. Let's just go ahead and use a few of them. We'll use these three here, red, yellow, and green. So here in birth, we're going to go ahead and use a generator, particle draw, and let's get into our top view and take a look. We're going to use two particle draws. So we hold shift and we can click and drag that operator to duplicate it. Or remember, you can hold alt and right click to remove. We're going to go ahead and draw a red particle. We're going to draw it roughly at the origin, and then we'll also draw a yellow particle, and we're going to put it out here kind of up in that direction. Okay, so let's go ahead and turn edit on the fly off so we get real-time updates, and let's take a look at using direction. Let's do this. Here's the thing, we need to be dealing with two particles at once, and whenever we do that, we typically are going to need to use a P-pass-AB. And a P-pass-AB allows us to specify either two of the same group or two different groups, and we can say red and yellow, and it's going to do comparisons between all of them. It's going to ignore the distance between them. We can limit it so it only compares particles who are within a certain distance, but for our purposes, looking at the distance condition, we can set it to all because we definitely want this red to compare with this yellow. Let's go ahead and throw that distance condition out here, and we'll just go ahead and blindly make these connections like this for now because we're going to look at the implication of that. And what we want to do is we want to go ahead and look at both the distance and direction outputs. So the way that we're going to do this is using the memory helper. You'll remember is, and actually we do not need a particle connection for that. Memory is a great way to debug scenes because it gives us the ability to expose any data type just about, and we can read that data because memory, you remember when you debug something, the value has to be used. So we're going to go ahead and create two values here. We'll create one called distance, and we'll just call it distance mem so that we can recognize it if we need to. And then the other one that we're going to expose, we could do a direction, but in our case I want to do a vector because you'll see why in a second. We'll go ahead and add these to the inputs. And what we're going to do now is we're going to connect that distance to the distance mem. You see that it only allows these two connections. They show up in green, meaning they're valid. And that's because distance is a scalar value. Well, it's a distance, but it's actually a float. And so the depth, it could either be used for the memory depth, which we do not want to do. Go watch the memory video for information on that. But the distance mem is the value we want. You remember, it is a scalar here. And then there's also the direction. We'll connect that, and then we're going to go ahead and we're going to write to debug log both of those values. Come up to master dynamic, turn on debug mode, and we get our debug window. Let's actually switch this view to the top view. Okay, and we'll scrub. We went forward one and back one. So here we are now on time 0. There was a time change of 160 ticks. And what we're getting in our debug window is we are seeing that the memory operator is giving us this distance mem value, and it's also giving us this vector value. And so this is what we want to do this so that we can explore what these values mean. Most simply, the distance mem obviously is going to be the distance between these two. We can check that real quick by adding a spline. Just create a spline line, put our mouse over that one, and then notice down here it'll read out the distance for us. So it's about 82, which is pretty much exact. So that's the distance. The distance is really easy, but it can be very useful. One of the best ways to use that is to control the multiplier of an effect. As the yellow particle comes closer to the red particle, that distance value is going to be updated all the time based on this current setup. And so you can use that distance to drive some other value to make the effect either stronger or weaker or whatever based on distance. The vector is more interesting, and that's the real one that we want to talk about, because the order of these inputs affects the direction, of course. Like right now we've got, we see our group A is the red particle and B is the yellow particle. What happens is, with red going into position 1 and yellow going into position 2, what happens is we get a, let's go ahead and draw this out here. This is P1 and this is P2. What happens is the vector that we're seeing here, look at this, the x component is negative 0.44, the y component is negative 0.89, and there's no z because they're just on a 2D plane. But this vector is basically, our x component is negative x, and our y component's negative y. So that direction, and it's actually a normalized vector. A direction is normalized, so the length of this direction is actually 1, like that. So it's very important to remember and know that with the red particle as position 1 and the yellow particle as position 2, even though this is our first position, this is our second position, it does not calculate that output direction in this direction. Instead, it's calculating it. It calculates it in the inverse. So if you want that vector to be from red to yellow, we duplicated that. If we want from red to yellow, you should think of these position inputs as position 1 being the final direction point and position 2 as the starting direction point. I know it's a little counterintuitive, but it's just how it works. So we can go ahead and we're going to take that red particle then. We want that to be the starting point, so we're going to put that into position 2. That's our starting point, is right here. And we want to calculate the direction toward the yellow, so the end position goes into position 1. And now we're going to see that when we update here, our vector is a positive x 0.44 and a positive y 0.89, which directly corresponds to what we see here, where this would be 0.44 and then a 0.89 there. So the length of this vector is always only going to be 1 because it's a direction vector. But now we get it at least going in the direction that we expect. So it's very important to remember that when using the distance condition. These position inputs, think of position 2 as your starting position and position 1 as your ending position if you want your direction to be calculated from position 2 toward position 1.